Hello everyone, I am Aditya Aggarwal and this video is for my TA application for the Computer Science Department at the UC San Diego. In this video, we'll look at how to delete an element in a binary search tree. But before diving in, let's look at what is a binary search tree or BST in short. A BST is a data structure which follows these following three constraints. First, every node in a BST should have a maximum of 2 children. Second, the left child of the BST should be less than or equals to the value of the parent node. Third, the value of the right child should be greater than the value of the parent node. So in this one, you can see these three constraints, that is 2 children, left child less than or equal to parent, and right child greater than or equal to parent, are all satisfied. So now let's look at what are the leaf nodes of a binary search tree. A leaf node is defined as a node which has 0 children. In this example, elements 10, 24, 42, 48 and 80 are our leaf nodes. And next is the height of a BST. So height of a BST is defined as the maximum distance of a leaf node from the parent node, from the root node of a tree. So in this case, you can see our root node is 40 and the maximum distance is the distance of 42, 48 or 80. So it is actually 3. So the height of a BST in this case is 3 and our leaf nodes are 10, 24, 42, 48 and 80. Now we know what a binary search tree is. Let's look at how to delete an element in a binary search tree. So in order to delete an element in a binary search tree, there are 3 specific cases, depending upon the number of children of the node that we want to delete. Let's look at the first case where we have to delete a leaf node. Let's take an example of deleting a leaf node, that is 10 in our case. So currently we have our current node pointing to 40 and we want to delete 10. Since 10 is smaller than 40, we go towards the left subtree. So our current node now points to 20. Again, our key to delete, which is 10, is smaller than 20. We again traverse towards the left subtree. So our current now points to the left subtree, that is 10. So as you can see that we have found our element which we want to delete. Since 10 has 0 children, we can simply delete 10 and point the left subtree of 20 to null. So after our deletion, it will look something like this. So we have deleted 10 in our case. Now let's look at case number 2 where the node that we want to delete has 1 child. Let's take an example of deleting the node number 20. So in our case, in this case also, the current node points to 40 in the beginning. The node that we want to delete is 20, which is smaller than 40. We move our current node to the left subtree. So now we have found a node which we want to delete, which is 20. However, we have one subtree of 20, which is the right in our case. So what we'll do is, we'll save the right subtree in a temporary pointer. So temp now points to 24 and we delete 20 now. So after we delete 20, so now we point the left subtree of our parent node, that is 40, to temp. So what will happen is, after deletion, if we just clear things up, so now 40 will point to 24. So as you can see, the constraints of our BST, which are the 3 constraints, that maximum, every node should have a maximum of 2 children, left child should be less than or equal to parent value, and right child should be greater than parent, are all preserved in our case. So we can say this is a successful deletion. Now let's look at the third case where we have 2 children of the node that we want to delete. So in our example, let's try to delete 50. So again, our current node starts from the root node, that is 40 of our BST. Our element that we want to delete, 50, is larger than our current element. We move towards the right subtree. So now we have found our element 50. So what we'll do is, we'll try to find the smallest element of the right subtree. In this case, the smallest element in the right subtree of 50, which is this subtree. So what we'll do is we'll keep on going towards the left of the subtree of 50. In this case, we'll first move towards 44. Again, 44 has a left subtree, that means there exists a smaller element than 44. We go to 42. So now 42 doesn't have any element, doesn't have any child. So that means 42 is the smallest element. So what we'll do is we'll store the value of 42 in the node that we want to delete, which is 50. So now 50, we'll remove 50 and store the value of 42. Now after removing 50 from this place, we'll simply delete 42. So in this case, it is simply our first case, which is we want to delete a node with 0 children. So that is 42. So now we'll simply follow the procedure for deleting the case 1. So we'll traverse the 42 and delete it since it's a leaf node. So now after deletion, our binary search tree looks like this. So as you can see, in this case also, the properties of the binary search tree are preserved. So now let's look at what is the time complexity of binary search tree. In each and every case, case 0, case 1, case 2, case 3, we traverse the tree only once, where we were trying to find the element that we want to delete. And once we find the element, we simply perform the operation, which again requires O of 1 time. So actually the time complexity for deleting an element in a BST is big O of searching the element that we want to delete, which is big O of h, where h is the height of the binary search tree. I hope how to delete an element in a BST is clear to you all. Thank you for your time.